Of all the energy from the sun, our eyes detect just a narrow band of 3 wavelengths: red, green and blue. Bees can see into the ultraviolet as well and navigate using polarized light, which to us is just glare to filter out with our sunglasses. But there's one animal that's got all that and more. It can see a world completely invisible to us. It's got the most complex eyes on the planet, and it's called a mantis shrimp. These strange and beautiful creatures are an ancient group of crustaceans known as stomatopods. Their stalked eyes move independently, each scanning the world in 3D. Where we see 3 colours in the spectrum, mantis shrimp see 12, their eyes detecting wavelengths that stretch from the infrared to the ultraviolet.
25 years ago, I discovered that these animals have a visual system which is most like a satellite. There's no other animal on the planet that possesses the ability to see so many colours, to see polarised light in the same way as these animals do.
Where do you find mantis shrimps in the wild?
Mantis shrimps are found in tropical oceans on the reefs and also in some of the temperate areas living in burrows in the mud.
They rare?
Not really. They're quite private, so you don't see them very often, but they're quite common.
Like a bee or a fly, the mantis shrimp has compound eyes made of tiny individual facets.
So their colour world is a complete mind-blowing experience for them in a tiny little brain.
But unlike any other eye, they also detect the 2 types of polarised light, linear and circular.
Polarised light is difficult for us to grasp because humans can't see it.
Light from the sun is non-polarised. That is, the rays vibrate randomly in all directions. When reflected, say, off water, light is polarised in the linear direction of the surface, in this case, horizontally.
When I put on my polarising sunglasses, they have a vertical polarising filter in them. What that means is they cut out horizontal light. By using a filter which takes that out, you remove the glare.
And then there's linear with a twist, circular polarised light. It's created underwater when linear polarised light scattered up towards the surface is reflected back down.
If I have a linear beam of light that's moving in your direction, it's vertical. If that beam then starts to rotate as it comes in your direction, that means it's circular, and it may rotate clockwise or counterclockwise, depending on whether it's left or right-handed.
In a world where water acts as a polarising filter, mantis shrimps are the only animals known to see both linear and circular polarised light.
These animals have been seeing and using circular polarised light for millions of years. So quite clearly, they have techniques up their sleeve that we can learn from.
They've already invented the prototypes of ultra-sensitive, high-definition optical devices we hope to reinvent now.
One of the things I've been trying to do is get shrimps in space. Trying to persuade the satellite engineers that we need to learn from biology. And this is now becoming a reality.
Inspired by the way that mantis shrimps scan the world across multiple channels of light, known as hyperspectral imaging, satellite sensors are being redesigned along the same lines. While the old Landsats measure light in 7 bands across the spectrum, new hyperspectral systems record 220. With this superfine resolution, they detect tiny differences in reflectance or chemical composition or temperature. Putting synthetic mantis shrimp eyes on satellites is improving the way we monitor the state of the planet from space, like the health of crops or the spread of pollution or shifts in the climate. DVDs and Blu-rays use filters called quarter-wave plates that change light as it passes through, but they only work on single wavelengths. The quarter-wave plates in mantis shrimp eyes work across all wavelengths and give us clues about making new and more powerful data storage devices. And then there's their talent for 3D vision, because each eye is able to distinguish between the different types of polarised light.
So when you go to the cinema these days and look at a 3D movie, you're actually using glasses that have left and right circular polarising filters in front of them. You're making yourself into a mantis shrimp.
But for the mantis shrimp itself, it's more than home entertainment. Having fabulous vision is all about finding someone to breed with and something to eat.
Mantis shrimp seem to be trying really hard to see every single aspect of light in the world, and discovering more about that is a joy.